In the heart of Wyoming sits a volcanic region so vast and powerful, it's earned the title of the largest active volcano on Earth. It's called Yellowstone, and you've probably heard of it. But did you know there are at least 5 others just like it scattered across our planet? Welcome to my channel, and today we're going beyond Yellowstone to unmask the hidden network of Earth's supervolcanoes. These colossal geological giants have the potential to unleash catastrophic events on a scale so grand they can reshape entire continents. Yet they remain shrouded in mystery. While the world keeps a watchful eye on Yellowstone, the other supervolcanoes quietly pose their own set of threats. We'll explore what makes these volcanoes truly super, the history of past eruptions, and the terrifying future that lies ahead. Let's start with a little context. The term supervolcano refers to any volcano capable of producing an eruption magnitude 8 on the Volcanic Explosivity Index, or VEI. To put that into perspective, the VEI assigns numerical ratings from 1 to 8 to describe the explosivity of volcanic eruptions based on several criteria, such as the height of the eruption plume and the volume of material ejected. A level 8 eruption is one of the most powerful events imaginable, releasing more than 1,000 cubic kilometers of material during a single event. For comparison, Mount St. Helens, one of the most active volcanoes in the United States, only reached a VEI of 5 when it erupted in 1980. Currently, there are approximately 1,350 potentially active supervolcanoes worldwide, but only about 40 have exhibited signs of activity within the last 2 million years. It's estimated that a supervolcanic eruption occurs once every 50,000 years on average, though this figure can vary greatly. The last major supervolcanic eruption happened about 74,000 years ago in Lake Toba, Indonesia. This eruption holds the record for the largest known eruption in the last 2 million years, with a VEI rating of 8. It unleashed approximately 2,800 cubic kilometers of ash and pumice, blanketing much of Southeast Asia and even affecting regions as far away as Antarctica. However, recent studies suggest that the timing of the eruption may be closer to 136,000 years ago rather than the previously believed 74,000 years. This shift in timeline has significant implications for understanding its impact on humans. If the eruption occurred 136,000 years ago, it predates the emergence of Homo sapiens by about 100,000 years. This suggests that early humans were not directly affected by the massive eruption. However, evidence indicates that the eruption had global consequences, including climate change due to the significant amount of ash and sulfate aerosols released. It potentially triggered an ice age and caused the extinction of some animal species. Yellowstone, the most famous supervolcano, is located in the northwest corner of Wyoming. It spans an area roughly the size of Yellowstone National Park, covering parts of 3 states, Wyoming, Montana, and Idaho. While the park was established primarily to protect the supervolcano, it also encompasses diverse geothermal features such as geysers, hot springs, and fumaroles. The most iconic feature of Yellowstone is the aptly named Grand Prismatic Spring, a massive hot spring renowned for its vibrant colors. Its name pays homage to the prismatic hues that paint its surface, creating a captivating spectacle. Yellowstone's history dates back over 2 million years. It consists of 3 major calderas, the areas formed by collapsed magma chambers. The oldest, the Yellowstone hotspot, is located in the northwest corner of the park. Evidence suggests that magma has been rising here for at least 17 million years, creating a chain of volcanoes known as the Yellowstone Line. The hotspot then moved south, forming the Snake River Plain and eventually leading to the present-day Yellowstone caldera. The supervolcano has experienced 3 major eruptions, the first 2 of which formed the Huckleberry Ridge and Mesa Falls Tuff. These eruptions were relatively small compared to later events. The most recent and largest eruption, known as the Lava Creek eruption, occurred around 640,000 years ago. It produced approximately 2,500 cubic kilometers of ash and pumice. During the late Pleistocene epoch, it dramatically reshaped the landscape, forming the Yellowstone caldera, which now hosts the geyser basins. While Yellowstone is considered the most dangerous supervolcano in the United States, its risk of eruption in the near future is quite low. Scientists closely monitor various indicators, such as seismic activity, ground deformation, and changes in gas emissions. Currently, these indicators do not suggest an imminent eruption. Despite its potential danger, Yellowstone is a popular tourist destination. Visitors can witness the beauty of its geysers, hot springs, and wildlife while staying at one of the park's lodges or camping in its designated areas. Yellowstone's eruptions have significantly influenced the surrounding environment. The fertile soils enriched by volcanic ash support diverse plant and animal life. The park is home to abundant wildlife, including bison, elk, wolves, and bears. Its forests cover vast areas, providing habitats for numerous species. Geologists continue to study Yellowstone to understand its behavior and potential risks. Research focuses on topics such as the frequency of future eruptions, the potential impact on climate, and the hydrogeological system beneath the caldera. The findings contribute to our broader knowledge of supervolcanoes and help inform hazard assessment. Now, let's venture further into the Earth's fiery depths and uncover the secrets of another supervolcano hiding in plain sight, La Garita Caldera in Colorado. Located high in the southern Rocky Mountains in south-central Colorado, La Garita Caldera is a testament to the raw natural power that lies beneath our planet's surface. This supervolcano holds the distinction of being the largest in North America and the second biggest on Earth, having unleashed itself upon the landscape around 27.8 million years ago. What sets the La Garita Caldera apart is its sheer size. With a diameter of about 50 miles, it dwarfs even Yellowstone. But the story of La Garita doesn't end there. It boasts the distinction of producing the largest known eruption in Earth's history. This colossal event, occurring about 28 million years ago during the Oligocene epoch, unleashed an astounding 5,000 cubic kilometers of volcanic material. That's equivalent to nearly one-third of the volume of all the water in Lake Superior. This monumental eruption earned a VEI rating of 8. But how does one discover such a hidden gem? The La Garita Caldera remained elusive until relatively recently because it's buried under thick layers of volcanic ash and rocks. It was finally identified in the 1980s through detailed geological surveys and remote sensing techniques. This remarkable find provided scientists with a unique opportunity to study an ancient supereruption and its impact on the surrounding environment. Despite its historical significance, La Garita isn't as well known as some other supervolcanoes. Perhaps its remote location in the San Juan Mountains contributes to this obscurity. Unlike Yellowstone, La Garita doesn't have the same grandeur and dramatic landscapes that capture the public imagination. However, it remains an active area of research for geologists seeking to unravel the mysteries of large-scale volcanic events. As we delve deeper into the topic of supervolcanoes, it's important to shed light on yet another enigmatic giant, the Taupo volcanic zone in New Zealand. Situated in the North Island of New Zealand, the Taupo volcanic zone is a geothermal wonderland that conceals one of the country's most awe-inspiring supervolcanoes, Lake Taupo. Lake Taupo is nestled within the North Island's central volcanic region, surrounded by picturesque landscapes that belie the power slumbering beneath its tranquil waters. But don't be fooled by its scenic beauty. This lake sits atop one of the most active volcanic systems in New Zealand. The supervolcano beneath Lake Taupo has a fascinating history spanning millions of years. It began its existence around 265,000 years ago, initially forming part of the Taupo volcanic zone. Over time, it grew and evolved, shaping the land and creating the lake we see today. The most significant event in Lake Tahoe's history occurred about 26,500 years ago when it produced the largest eruption in New Zealand's history. This massive eruption, rated as a VEI of 8, unleashed an astonishing 300 cubic kilometers of volcanic material. It led to the formation of the current caldera, which now houses the lake. Today, Lake Taupo stands as a reminder of the awesome forces that shape the region. It's a popular tourist destination, attracting visitors from around the world. Tourists can indulge in water sports, fishing, or simply bask in the serene beauty of the lake. They can also visit the nearby Hookah Falls, known for its thundering waters plummeting 30 meters down a narrow gorge. However, it's essential to acknowledge the volcanic risks associated with Lake Taupo. While the risk of an eruption is low in the near future, it's impossible to predict when volcanic activity might resume. Scientists closely monitor various indicators to assess any potential hazards. And our journey takes us across the globe to the Katmai National Park in Alaska, where we encounter a supervolcano that's a true giant among giants, the Novarupta. The Novarupta is a stratovolcano, a majestic yet formidable peak standing tall in the heart of the Alaskan wilderness. This stratovolcano played host to one of the most violent eruptions of the 20th century, capturing the world's attention in 1912. The eruption of Novarupta was nothing short of catastrophic, leaving an indelible mark on the landscape and the surrounding environment. In June 1912, the volcano erupted violently, sending a massive plume of ash and pumice high into the atmosphere. The eruption column rose to an estimated height of 37 kilometers, casting its shadow even over the Arctic Circle. The force of the explosion was so immense that it could be heard as far away as Seattle, Washington. In the aftermath of the eruption, the landscape was dramatically reshaped. Novarupta's slopes were scarred, leaving behind a valley filled with volcanic debris. Ash blanketed the surrounding area, creating a layer several meters thick. The eruption sent an estimated 3.6 cubic kilometers of ash and pumice into the air. This monumental event left an enduring legacy on the ecosystem of the region. The eruption's impact extended beyond the immediate vicinity of Novarupta. Ash was carried aloft by winds, traveling thousands of kilometers across the northern hemisphere. Some accounts even report ash falling in places like Minnesota and Florida. The eruption caused significant ecological disruptions, affecting plant and animal life both locally and globally. The massive ash cloud also had profound effects on global temperatures, leading to a slight but noticeable cooling. The year 1913, following the eruption, was one of the coldest summers on record in many parts of the world. Today, Novarupta stands as a testament to the raw power of nature, reminding us of the awe-inspiring forces that shape our planet. Its eruption remains a pivotal event in the history of volcanology, providing valuable insights into the behavior of supervolcanoes. The scars left on the landscape serve as a tangible reminder of the eruption's impact. And for those who venture into the Katmai National Park, the site of the Novarupta, the experience is both humbling and thought-provoking. Our exploration of supervolcanoes takes us to a remote region of Chile, where hidden amidst the Andes Mountains lies a supervolcano that remains shrouded in mystery, the Chaitén. The story of Chaitén is one of dormancy broken, revealing a powerful force that had lain hidden for centuries. For many years, the presence of a supervolcano in the region was unknown. It wasn't until 2008 that Chilean authorities became aware of its existence. What followed was a series of remarkable discoveries that shed light on the true nature of this slumbering giant. In May 2008, the Chilean National Geological and Mining Service detected a swarm of earthquakes near Chaitén, indicating an awakening after a long period of inactivity. Soon after, a steam vent was observed emitting sulfur dioxide gas, marking the initial signs of the volcano's resurgence. The steam vent marked the beginning of heightened volcanic activity. As days passed, the steam became tinged with ash, signaling an imminent eruption. On May 2008, Chaitén erupted with a force that surprised many. Ash and gas spewed into the sky, reaching heights of 15 kilometers. The eruption caught local residents off guard, prompting evacuations and disrupting daily life in the surrounding areas. The eruption of Chaitén serves as a stark reminder of the unpredictability of volcanic activity. It demonstrates how, even after prolonged periods of dormancy, a volcano can awaken and pose significant challenges to nearby communities. The eruption's impact extended beyond the immediate vicinity of the volcano. Ash was carried by winds, affecting air quality and causing disruptions to transportation and daily activities in nearby towns and cities. Since its eruption in 2008, Chaitén has continued to exhibit signs of volcanic unrest. Scientists closely monitor various indicators to assess the volcano's behavior and potential future eruptions. Now let's turn our attention to the Toba, a supervolcano located in Indonesia that holds significant importance in our planet's history. The Garita Caldera, nestled within the Batak Highlands in North Sumatra, Indonesia, is a place of both natural beauty and scientific intrigue. This colossal structure is home to Lake Taupo, a mesmerizing body of water that occupies the caldera's vast basin. The story of Toba dates back 74,000 years, when it experienced one of the most significant volcanic eruptions in recent history. This mega-eruption had global repercussions, leaving an indelible mark on the course of humanity. The explosive eruption of Toba sent an estimated 2,800 cubic kilometers of ash and pumice into the atmosphere, forming a layer up to 6 meters thick in some areas. It's believed that the eruption triggered a volcanic winter, causing global temperatures to plummet and disrupting climate patterns worldwide. As the ash cloud enveloped the Earth, it blocked sunlight, leading to a prolonged period of darkness. This eerie stillness allowed for a clearer view of the stars, leading some to refer to the night sky at that time as the second creation. But the impact of the eruption went beyond darkness. It brought forth a new dawn in human history. Some theories propose that the eruption of Toba coincided with the emergence of Homo sapiens, giving our species a unique opportunity to thrive in a rapidly changing world. The harsh conditions presented by the volcanic winter may have acted as a crucible, fostering resilience and adaptability in early humans, contributing to the cognitive and technological advancements that characterize our species today. This eruption not only shaped the planet's climate, but possibly the very trajectory of human evolution. Today, Lake Toba stands as a testament to the eruption's colossal scale. The caldera's immense size and the lake's breathtaking beauty serve as constant reminders of the forces that have shaped our planet. It's important to note that while the eruption of Toba had profound implications, it's not universally accepted as the sole cause of significant events in human history. Some researchers question the extent of its global impact, while others highlight the lack of conclusive evidence linking the eruption to major genetic bottlenecks in human populations. Nevertheless, the eruption of Toba remains a pivotal event in the annals of volcanology and fuels ongoing scientific discourse and exploration. Supervolcanoes like Yellowstone, Garita, Taupo, Novarupta, and Toba are truly awe-inspiring phenomena that remind us of the immense power our planet holds. Their potential impact on a regional or global scale highlights the need for continuous monitoring and research. As we learn more about these supervolcanoes, we gain a deeper appreciation for the forces that have shaped and continue to influence our world. If you enjoyed this episode, please don't forget to subscribe to stay updated with our latest episodes. Thank you for joining me on this journey through the hidden network of Earth's supervolcanoes. Until next time, keep exploring, keep questioning, and keep discovering.